Okay. Welcome everyone. Thank you for coming to today's shell scripting workshop. My name's Eugene, and I will be your, I was going to say tour guide. I'll be your teacher for today. Before all that, here's a couple of logistical stuff. If you want to follow along with these slides on your own computer, this is the link for that, tinyurl.com/tooling3. I also provided the link to the README plus the code. And this is like if you want a more detailed overview of everything I'll be going over today. And finally, here's the attendance code for today if you want to get some points for the membership portal and win some pretty cool prizes at the end of the quarter. Yeah. So today I'll be going over a couple of things. I'll be going over some useful commands that you can do on the shell, as well as some fun terminal tips and tricks. And then Christy, another hack officer, will take over to show you guys what shell scripting is and what exactly you can do with it. So first and foremost, what is a shell? A shell is a command line interface program. So command line interface, back in the olden days, back when Professor Eggert was just a wee little lad, the only way you can interact with a computer was through a physical terminal, which was called a command line interface because you can only put text inputs through a keyboard. And this is different from what we're used to now, which is on our own computers, which is called a graphical user interface. And this is what allows us to use a mouse and click on different graphics on our screen. But with a command line interface, you worked with what was called a shell, which is a program that takes commands from the keyboard, it translates it, and then it gives it to the operating system to perform different tasks. And through this interface, you were able to, as a user, gain different operating system resources, like you can get information about files or directories. And nowadays, even though that our computers are graphical user interfaces, we can still interact with the shell using something called a terminal emulator, which pops open a window on your computer and allows you to put these commands in the same way that you used to. And there have been a couple of examples of shells that have grown over the years, and they all sort of more or less originated from the original Bourne shell, which came along with the Unix operating system. And this was the first shell, and it defined a lot of the different models that we're used to today. After this, over the years, there have been a lot of different versions, basically software updates to this original Unix shell. The one that most people think of and that's the most famous is Bash, and that's what we'll be focusing on today. Other alternative Unix shells are Z shell, Corn shell, and something that just came to my attention recently is Fish shell, which is, I think, open source, and it's a more interactive and visual terminal. And it has a lot of like customization built into it that other shells have to sort of manually put in. And this last one is sort of the odd one out for command prompt for Windows, just because it wasn't like an extension to the Unix shell. So a lot of the commands, or actually all the commands, are different for the command prompt as opposed to the commands for Unix shell. And for today, all the commands I'll be showing you are Unix commands. Sorry, Windows. But if you wanted to follow along, I provided in the README a couple of ways you can also get Unix and Bash into your own system. So yeah, today we'll be going over mainly Bash, just because it is the most common one that people think of. And it's the default login shell for most Linux distributions and the Mac before Catalina. Now it's Z shell. But the principles of Bash translate pretty much over to all shells that were like based off of Unix shells. All the commands are really similar. And what Bash stands for is the born again shell. And that is, I put little finger guns because that is a double pun. It's a pun both on the fact that the original shell was Bourne shell, and this is like born again, so it's like an iteration, but also because it's like a rebirth of the shell. You know, we like to have fun here as programmers. But anyways, Bash has added a lot of different features to the original Bourne shell. Most notably, it added command history. So you're able to access commands that you've recently put in the past, so you can like keep repeating them. But also you can autocomplete commands, which is really useful for the dev or the developer workflow. So why exactly would someone use Bash? Bash, first and foremost, is able to run programs and execute files, which in Bash you would call commands. And these programs they can be built-in programs like Vim, which is a really cool text editor, or Emacs, which is like a text editor. And it could also run programs that you build yourself. So if you have something in C++ that you compile down into a program, you can easily run that in Bash. Bash also has its own scripting language, and through this you can do shell scripting. And shell scripting are like little programs that you can write yourself to automate a lot of processes that would otherwise be really repetitive or boring. And that really helps. So with all these tools, Bash is a really essential developer tool. And I would liken not using Bash or just the terminal to an analogy where you would drive a car without a steering wheel. Sure, like without a steering wheel, you're able to stay straight and drive forward, but you miss out on a lot of different features from turning left and right. There's also the fact that you're like a literal safety hazard when you don't have a steering wheel, but that's not as relevant for this analogy, so let's just look past that. So anyways, like with all these tools and functionalities on the terminal, you're able to run commands immediately and really quickly. And there's actually a couple of commands that you're only able to run on the terminal and otherwise can't do on the graphical interface. But as the overused quote goes, with great power comes great responsibility. Because sure, you can run these commands immediately without warning, but at the same time, you can run these commands without warning. And if you're not completely sure about what you're doing, this can have massive like negative side effects. So the major goal of today is to try and teach you guys some useful commands, but they're not only useful, they're relatively safe. We won't be getting into something called sudo, which is a command that gives you root permissions. That's really error prone, and if you don't know exactly what you're doing, it will cause trouble, and we do not want to be held liable for that at Hack. So I've basically hyped up Bash to be this really good developer machine, and maybe if you haven't heard about it in your head, this is what you think it looks like, but in reality, it's really just like a practical tool, so it looks more like this. So not as flashy, but definitely still practical and really useful, and definitely something you should want to bring into your workflow. So with all that being said, let's take a look at a couple of common Bash commands. And all of these more or less have to do with navigating or just interacting with the files and directories on your computer. Whether it's changing what file you're looking at, or creating files or creating directories, all these are really like useful commands that give you a lot of information about your operating system resources. And they can also be chained together to create even more powerful commands. But before diving into that, I just wanted to take some time to look at how Unix looks at these different files and directories. So you might be more used to the left side on your own computer where you see different folders, and these folders can contain other folders, which in turn can keep containing subfolders until finally you hit files that are in these subfolders. Well, what Unix looks at these files like, and how we're going to look at them today, is more like a directory tree. And with this upside down tree diagram, you start everything from the root directory, which in Bash is represented by the /. And this directory contains every single other file and directory. And the way you can see how they're linked together is this directory contains, or in this analogy, it branches out to other subdirectories, which in turn can also contain and branch out to other subdirectories until finally you reach the endpoint, which are called leaves. And they are files that you can interact and manipulate. Cool. So let's get into the demo. I'd like to preface this with saying that we don't want you to follow along today, just because with all these different systems, there's a lot of different downloads that you have to go through. But you guys are free to try this on your own time. I've also provided, like I said, the different downloads of your Windows and stuff. And I provided a reference sheet too of all the commands I'll be going over to today. Cool. So let me open a fresh terminal. And for me, I have my shell logged in on Bash, but if you're another Mac user who has Catalina, updated, you probably maybe changed your default shell to Z shell. In this case, you can just run the bash command, and that would run bash, just like I have right here. Cool. So the first command I'll be going over is pwd, which stands for print working directory. And once we press enter, we can see exactly the path we took to get to this point, this current directory. And if you think back to the directory tree, this is as if we're saying we started on the root directory, which is the /, and then we navigated into the users directory, which contains the owner directory, and then we navigate into that, which is what we currently are in. Awesome. So what if we wanted to see what this directory contains? The way we do that is through the ls command, which is short for list. And once we do that command, we can see every single file and directory that's located within this directory. So we can see this directory contains desktop, it contains documents, it contains downloads. So by itself, ls will show what's currently in your current directory. But let's say you wanted to see the contents of another directory. For example, let's see what's in desktop. In that case, what you would do is do ls plus the directory you want to look into, which is desktop. And now we can see all the contents of desktop. And if I crack open my Finder, my file system right here, you can see that I am not a fraud. And it in fact contains the directories and the files that you can see on here, plus all these screenshots. I'm super disorganized. Okay, so we can see what's in our current directory and what's around this directory. But what if we wanted to be able to jump into another directory or navigate into this directory so we can work with that instead? So how we change the directory we're currently at is through another command called cd, which is short for change directory. So if I wanted to list contents again, because I forgot what's in my computer. If I wanted to change directories into this desktop directory that I saw the contents of, then I would just do cd plus desktop. And if I press ls into this current directory, we have the same exact output that came from this when I did ls desktop. And what I just specified there when I did cd desktop, that's what's called a relative path. And in bash and shell, there are two different types of paths you can specify. There's the relative path where you type in like the directory you want to go into relative to the current directory you're in. But there's also the absolute path, which is the path that you need to get to based on the root directory. And how you do absolute paths is by specifying starting from the root directory where you go. So if I wanted to do the equivalent command of what I just did with the absolute path, I would do cd / users, I think it was, owner, and then desktop. And then this would be the exact same thing. Okay. There are a couple of special keywords when it comes to cd and a lot of other commands that I just want to go over really quick. For this, I'll have to flip back to the presentation. So for cd and all of the other commands, there are a couple of things you can do, or special keywords. And these are current directory, parent directory, root directory, and home directory. And the way you specify them are using these keywords over here. So as you can see from this very not well-drawn diagram, you can see what these different keywords have on the bash, or like when you do the commands. So when you do cd dot, which is the current directory, basically all it's doing is it's just going back into the current directory, which isn't too useful, but it's a lot more useful on other commands. And if you do cd dot dot, which is the parent directory, you will go back to the parent directory that contains this directory, and you can then see this directory when you ls. There's also the root directory, which CDs right into the directory that contains all the other ones. And then there's this tilde one, which is the home directory. So the home directory is the one that by default pops up when you open a terminal. And for us, it was /users /owner. So if I quickly play around with this, if I do cd dot, That really isn't doing much. I mean, we're in the same directory, but you can see that it works. We can otherwise do cd dot dot for the previous or parent directory, and we go back into the homeowner one. And if we ls again, we can see that desktop is located there. If we do cd /, we will go into the root directory. And if we print working directory here, it's literally just a /. And then if we cd back into the home directory, we will be back where we started, /user/owner. So yeah, cool stuff. For the purposes of this demo, I'm gonna go back into the desktop because I have like a special made folder there. I'll just take this time to also show you what I was talking about when I mentioned earlier that you can use your command history. And the way you can see that command history is by using the up and down arrow keys. So if you press up, you can see the command that I literally just did, print working directory. And if I keep going up, I can see the exact history, and eventually I'll get to this one. And if I press enter, we're good to go. I'm back to desktop, and I will cd one more time into the folder, which is for me bash demo. Cool. Let me ls to show you guys what we're working with. We're working with 3 subdirectories. Yeah. So the next command we'll take a look at is touch. And touch is how you create files in bash. So if I wanted to create a file called, in my infinite creativity, file.txt, we have successfully created this file. And if I ls, it now exists in this contents. And to let you guys see that I'm not, in fact, not lying, we can see that the file exists right here. Cool. Another way to do this, which you guys might have already been doing, is if you use a terminal text editor like Vim or Emacs, you could easily also do the same thing by just saying Vim and then a file that hasn't been created yet. So I'll do vim file.txt. And if I just write to this or save, however you do that on your text editor, and then I quit, you can see that this file is also created. So it's really down to preference on how you want to create it. If it works like you're going to go into Vim, you can just do that. Okay. Now I will show you make directory, which is make dir. And that's the same thing as touch, except this time you're making a directory. So if we specify make dir plus the name of a directory we want to create, so I'll just say directory. We have now created a directory, and you can see right here, it has also created it over here. And we can cd into it and do a lot of different things as we would otherwise be able to do for any directory. Well, because it is a directory. And something I forgot to mention for, something I forgot to mention for both touch and make dir is that if you put more than just one name after, you can make multiple files or directories at one time. So if I do make dir, dir1, dir2, dir3, this will make 3 separate directories. And this, similarly, if I do touch, file1.txt, file2.txt, and file3.txt, that will successfully create 3 files. And I don't know if you can see on the side, but yeah. Okay, next up we have move, which is mv. And mv serves 2 purposes. The first purpose is it moves one file or directory into another directory. And the second purpose is that it can rename files. So let's take a look at the first one. If we do move file.txt, which is what we just made, and we want to move it into, let's say, subdir1, the first argument would be file.txt, and the second one would be the one that we want to move into. And once we ls here and see what's in subdir, you can see that file has now been moved here. Similarly to touch and make dir, you can also do the same thing with multiple files. If you want to do file1.txt, file2.txt, and file3.txt, and you wanted to move all those into subdir1, you can list as many arguments as you want, but the last one has to be the directory you want to move it into. And again, if we do ls subdir1, we can see that all these files now exist here. So now let's look at the second one. Move can also rename files. So I'm just going to quickly make another file, file4.txt. If I called move on this file and say this file is file4.txt and I want to rename it, the second thing that comes after is what you want to name it to. So I'll just call it file4rename.txt. And once we ls, we can now see that it has in fact changed to this name. We can also sort of do both of these purposes in one command by saying if we wanted to move file4renamed into subdir but also change its name, we can say move file4renamed.txt into subdir1, but also we want to change it to file4moved.txt. And once we do that and list up the contents of subdir1, we can see that it now exists in this new subdir directory. And just to make sure, let's ls in the current directory. And as expected, none of these files are located here because they're all in subdir1 now. Okay, next up we have cp, which is short for copy. And it does the same thing as move, but at the same time, it copies it over instead of moves it over. So if I cd into subdir1, I want to copy, let's say, file1.txt. So I'll do cp file1.txt. And let's move it into our parent directory. And let's use the keyword we learned, ... And if I list the contents of the parent directory, we can see that this file is now here in the parent directory. But if we also list out the current directory, it still exists in this file. So it has created two copies of the same file. Something different though between copy and move is that if I try to, let me cd out, sorry, let me cp. If I try to copy a directory and move it into the parent directory, it'll throw an error and it'll say there's no such file or directory. Probably because there's no such file or directory here. That is my bad. So if I ls here and I try to copy it in the other way into subdir1, it'll throw this error, which is dir1 is a directory. And the reason for this is that copying as opposed to moving requires a lot more work when copying things, because not only do you have to copy the directory outside, you also have to copy the contents inside, like the subdirectories in the files. So there's an additional extended thing we have to add to this, but I'll get back to that later. Okay. Next up, we have rm, which stands for remove. So let me preface this one by saying, remember when I said that commands can be really dangerous? Well, never is this like more apparent than this command, because when you rm or remove something, you're not just like moving it into like the trash can or like the recycle bin. You're like literally removing it from your system. So you have to be like really careful that you're removing what you want to. Someone I know, not naming names, I think accidentally removed like half of his operating system. So there's things that you can do. You just be careful. For this one, let's go into subdir2. Let's list out the contents that are in here. And what's this? You have 3 toxic people? Let's see what they have to say to me. Cool, you suck. That's fine. People are entitled to their opinions. Okay, person 2. You'll never be enough. You know, that's fine. Toxic person number 3. You are 5 feet 8 inches tall. That is ridiculous. I'm 5 foot 10 inches. Okay. Let's just remove all of them. So something I haven't gone over yet is there something that you can do to make your commands more efficient? And that's using the wildcard operator. And how you can specify this is with a star. And what a star or wildcard operator does is that it'll match up with, excuse me, it'll match that star with 0 or more characters that follow. So in this case, anything that starts with toxic and has anything after that will be removed. In this case, since they also have person in common, you can also put wildcard in the front and put star person. Well, I guess in this case it doesn't work because there's different numbers, but you can also do this, and that would work as well. So let's go ahead and remove these toxic people. And if we list contents, there's nothing in here. If only it were that easy in real life. Okay. So at the same time, this rm command has the same problem as cp, where if you try to remove a directory, like subdir2, it'll throw an error. Oh my god. If you remove subdir2, it'll give you the same error that it's a directory. And again, you have to give an extended feature to it. I'll cut the suspense. Let's get into that right now. So with all the commands that I showed you today, you can also add something after that are called options. So these are like flags that you set that extend the functionality of all the commands that we've done. So if you do like -a, -l or something, that'll add more information or functionality to it. And I want to show you a couple, but before I get into that, I'll show you how exactly you can look up these commands or these options to see what you can do. And that's with a command called man, which is short for manual. And if you man plus a command that you want to see the options for, like let's in this case, let's say ls, this will open up a manual page and you can read all about ls. And you can see all these different options it specifies. And for those of you guys who used Vim before, man pages use Vim-like controls. So you can press J to go down, K to go up. And we can see a bunch of these like dash letters. A couple I want to bring to attention today, and I'll be going over, is this -a, which includes directory entries that begin with a dot. And let's also go over -l, which is list and long format. And you can quit the man pages again, like in Vim with Q. Really quick, I'll also go over some alternatives for man, because man pages often go too much in detail and it's like a little intimidating. If you just wanted to know what options a command has, you can also do ls-help or any command -help. And you can see all these letters that you can specify after ls. But another resource that has come to my attention recently, I'll just pull it up really quick. Or will I? Hold up. I guess not. But another resource that has come to my attention is called TLDR. And if you search in the engine at the top and like with a command that you want, it'll give you more like human readable description of the option. I linked it in the README if you want to have access to that. I've been using it. It's really helpful because man pages can get like a bit confusing at times. But okay, so let's go over those options I mentioned. So if we do ls-a, actually let's go over ls-l first. So if we do ls-l, doing this will not only list out the contents of what's inside the directory, but it'll also give you a lot more information about different details about the command, the directories. And we can see all the files we've had. We can also see the time we made these files. And we can also see how much memory or like space they take up. And you can see that these files here don't take up any space. That's because we haven't written anything in them yet. So if I do vim file1.txt and I write a couple things in it, and if I ls-l again, you can see that this same file now has 10 bytes of space. And you can also see here that this timestamp right next to the file is different. So here you can see it was 1830 and here is 1837. It's because these timestamps sort of specify when the file was last modified or updated. So now let's go into ls-a, which if you remember, lists out all the files. So also the ones that start with a dot, and in bash, files that start with dosh or like hidden files. So if we do ls-a here, we can see these hidden files that start with dots, which, if you might have guessed, is the dot, which are the current directory and parent directory. And oh, whoa, what's this? What's in this file? Nice. Okay, let's go over how you can copy and remove directories instead of files. So if you recall, if you just do the base cp command, you're unable to copy directories. But if you say cp-r, you can now work with directories. And what -r stands for is like recursive. So not only are you copying the directory itself over, you're also copying the directories inside over and the directories inside those over. And then you keep doing that until you reach the base level, and then you copy the files over. So if we copy all our directories, so dir star, and we move it into subdir 1, or let's do subdir 2. And now if we list out the contents of subdir 2, we can see that all of these directories have been copied over. And similarly, if we wanted to remove directories, we would do the same thing, remove -r. Let's delete the directories from this current directory. So remove -r dir star. And if we list out the contents, we can see that these directories no longer exist. Okay. So that does it with the base Linux commands. I'll go over a couple that are a little more complex. First and foremost, this screen's getting a little cluttered. So what we can do is use the clear command. And all this does is it just like sort of wipes the slate clean. You can have a fresh terminal again. Let's also go over find. So what find does is it finds different files and directories in the directory you specify, but you can also add different like flags or like options that look for specific things. So in our case, let's try and look for all the files in our all the files that end with .txt. And how you would do that is you would do find plus dot, which is the current directory, or any directory you want to look into. And we want to see which ones end with txt. So we would say -name, which is how we would raise the name flag, and then the sort of pattern that we want to look for. So star.txt. And once we do that, we can see all the files that end with txt, not only in this current directory, but all the different subdirectories that it contains. Okay, next up, let's go over cat, which is short for concatenate. And what it does is it prints out and to the terminal what is inside a file, but also it can also concatenate files. So let me actually put stuff into a file. Let's do file1.txt. Okay, wait, actually I already put stuff in here. So if I cat that file, we can see that these are the contents of the file. And for the concatenation part, let's make another file called file2.txt. I don't know what to put in here. Just put a bunch of tildes. Okay, so if you want to concatenate these two files together, all you have to do is put both of them into the same command. So first put the file that you want to see first, and then the file you want to concatenate the stuff after. Once we enter that, you can see both of them have been displayed to the terminal back to back. And let's say you don't just want to see this in the terminal, but you also want to be able to store it into another file. And in Bash, there's a special operation for this. So let's take the command that we just did using the up arrow, and we'll do something called redirection. So normally it would just be printed out into the terminal, But using this operator, which is the greater than sign, we can take what would normally be outputted to the terminal and instead redirect it into another file. Let's just call it file3.txt. So once we enter this, we can see that nothing was printed out into the terminal this time. But if we open up our file3.txt, this exact same output has been put into this file. Okay. Next up, let's go over grep. Let me cd into another subdirectory for this. So what grep does is it searches for a pattern that you as the user put down inside a file, and it will output to you all the lines that follow that pattern. And how we can set this is by using grep and then the file. Let's see what files we're working with. Okay, b.txt. So what b.txt is a text file of the entire B-movie script. Why I have this, I have no idea. But if we wanted to see all the lines in the B-movie that say the word B, what we would do is grep out that pattern. So we would say grep plus the pattern we're looking for, which is B, and then the file that we want to look inside, which is b.txt. And once we do that, we can see all those lines. There are a lot of lines. But you might be wondering, where in this pattern will it let me see different patterns like a capital B? And once again, we can use an option to extend this functionality. So if we do grep, but this time we do the -i option, which means ignore case. We don't care about case. And then do the same thing with B and then b.txt. We can see the same output, but also we can see other outputs that we haven't seen before, including, which I think is the best line in the movie, B. Really, really emotional line. Okay, but let's just say that we didn't want to see all these lines, and all we cared about is how many lines of B's there are. And for this, we would add another option, which is C. And when you do multiple options, instead of like having to say -i-c, you can just put them together in one like dash option. So you can just say IC. And then again, b.txt. We can see that there are 161 lines of B in the script. Okay, so although the grep command has an option that lets you see the lines, there's a separate command that gives you a lot more flexibility when it comes to counting things, and that's word count, or WC. So if we wanted to say word count b.txt, this would give us a lot of different information about things we can count in b.txt. First, it outputs the number of lines in b.txt, then the words, then the number of bytes or characters. But if we just wanted to see like one of these columns at a time, again, we can say some options. So if we wanted to just see lines, we would do b-l, b.txt, and that would give us this first column, which is the number of lines. We could do -w for the words, and that would give us the second column. And finally, we can do w word count .-c and then b.txt, which would give us the last column. Awesome. So the last thing I want to do with commands is show you how we were able to chain these commands together. Because sure, like you can do these commands by themselves, but things become a lot more flexible and powerful once you combine them together. Okay, we have a question. Can you call these word count and grep commands on multiple text files at once? It's to my understanding that you can't, but someone in the hat can correct me. Oh yeah, you can use cat. Okay. By itself, can someone in the hat confirm? I don't think by itself grep can do multiple files. You'd have to use piping. But yeah, let's look at that right now. So with piping, you're able to chain multiple commands together. And what that means is that once you run a command, you can take that output and then you can feed it into the input of another command. And you can just keep doing this until you're satisfied or you get the output you want. So as sort of a cumulative review, let's just go over all the commands we've gone over and then chain them together to see what they do. So first, let's cat out our b.txt so we can get the output. And then once we get that, let's take the output and feed it in or pipe it into a grep. And how you specify a piping option is with this symbol, which sort of looks like a pipe, I guess. And then let's take out all the instances of b in this file, b.txt. Sorry, the pattern itself. And once we have taken out all of the b lines in this cat command, we can then feed that output into a word count. And we want to see maybe how many words are in these lines. So once we have all these commands together and we press enter, we can see 772. So that's giving us how many words are in the lines with B. So, I mean, you guys are like, I don't know, this is some information you can use at a party or something, I don't know. But I mean, now you know. Oh, yeah, Daniel, the double quotes are optional. You can do them, but it's just like a style choice. Okay. So that does it for all the bash commands. Next up, I want to look over some fun terminal tricks that you can do. And these are some things that you can do just to like make your life easier, or I guess in customization's case, prettier. So we'll go over how to open files in graphical applications, aliases, key binding, and customization. So let's start with opening files in graphical applications. One thing that you can do, and I apologize for non-Mac users, I think it's only for Mac, is open. I think there are equivalents for like Linux, but it goes under a different name. And what you can do with open is you can simulate or do exactly what you normally do when you like see a file and then you double click it in the Finder. You can do that straight in the terminal. So I don't think I want to do it on the B file. Let's just do the same one. So if I press open and then file1.txt, you can see that this does the exact same thing as just opening it in the Finder. And this saves a lot of time if you're like already in the terminal and you just want to see how something looks graphically. Another one you can do, another option that you can specify with open is the -A. And this one allows you to be a lot more choosy with what application you want to open it with. So if you follow -A with like an application that can open a text file, so let's say Sublime Text, and then the file you want to open, this will open it in Sublime Text instead of that text edit app I had. And you can also do this for Visual Studio Code, but the people over at Visual Studio Code also have given us our own command for opening that, which is, I think, a lot more easy to write than all this out, which is just code plus the file. Okay, give me 1 second. This is a little bit of a spoiler. Okay, let's try that again. Okay. Well, in theory, it will open up VS Code. Promise me, or trust me, it's pretty cool. Okay. Let me just clear this. Next up, we have aliases. And what aliases are things that you can define, or names you can define, that take the place of another. So if we think back to this command I did, open-a sublime text, that's like a really long command, and honestly, it would probably be faster if you just clicked some like sublime text like graphically. But what you can do is instead set an alias for this. So whenever you call this alias, you are actually under the hoods calling this entire command. And how you can set an alias is you say keyword alias plus what you want to replace that text with, which is Sublime, and the command you want it to represent. So for any command that takes more than one space, you would use single quotes. So we'll say open-a with Sublime text. Oh, sorry. And oh yeah, I think that was a happy accident because I forgot to go over how to cancel commands. What I just did right there was I accidentally forgot the single quote. And what that caused terminal to do was accidentally, or expect more things to come after. And if something like that happens, don't panic. The way you can escape commands just to start from the beginning is with Control-C. And that goes for both Mac and Windows. It's Control, not Command. Okay, let's try that again. This time putting the single quotes. Okay, so now if we do Sublime plus the file we want to do, that'll do the exact same thing we did in a lot less lines or a lot less words. And if you wanted to be super fancy, you could have just done S, but I kind of want it to be more readable. The problem with doing all this stuff inside your terminal is that it only works for this one like specific window for terminal. Once you open another one, like if you do it on another day, like that alias will be gone. So how exactly would we make this persist or like make it work for every single time we open up terminal? And how you can do that is with something called bash profile. And that's a hidden file that exists in your home directory. If I go into that using vim, we'll do home directory /bash profile. You can see a lot of different contents on this that set up like different customization features for your shell. And this is what runs every time you open up terminal. I should also preface this by saying that for Mac, the file that opens, that starts when you open terminal is bash profile. I think for Linux, it's bash source, and I'm not too sure what it is on other systems, but just be careful like which file is run. But yeah, in my case, it's bash profile. So if we added that alias down here as alias Sublime equals open -a Sublime text. And then if we save this file, and then if we restart our terminal, and then try cd into desktop/bash demo, and then use that Sublime command again on our file 1, we will open up in Sublime. And what I just did there when I like skipped a lot of different typing is I used the auto complete feature that bash added. So if you say file 1 and then you just press tab, you'll automatically complete it with the file that or like mirrors that letter or the lettering at the beginning. Okay. A couple more things. We can also do key bindings in bash. So how you can see all the key bindings that have already been set is by using the bind-p. And you can see a bunch of these different commands that you can set. Ones that I want to bring attention to, and I will use the grab command for this. It's a learning process. Okay, so the clear screen can be found on the Control-L. And remember how we were doing like this clear word? Some people just prefer using the keybind Control-L, and that'll do the exact same thing as using clear. Another one I want to bring attention to is the reverse search history. So if we search that up, reverse search history, and we'll look at this one. That can be found on Control-L. And what this does is if you press Control-L, you start a reverse search. And instead of doing the up and down arrows to look for your command history, if you already know what command you used to do, if you just put CD, you can see every single command you've done in your like recent past that starts with CD. And if this isn't the one that you want to look for, you can cycle through all the CD ones that you've done before by using typing again Control-L. So this will keep cycling through until I find the one I want. Let's say subdir 1. And then if you press enter, it'll just run that command for you. Okay, last thing I want to look at is shell customization. I don't know about you guys, but maybe this black and white like background thing gets kind of tiring sometimes. So how exactly will we spice it up? Well, if you think about the bash profile file I was talking about, it's not only to put like persistent aliases in, you can also open it up to customize your bash terminal even more. So I commented these out for dramatic effect, but if I uncomment this line, this will set the prompt message that you get every time you set a command. So right now it's like on the left side, it's like owner $ for me, but this will set it exactly to what I have right here. Let's also uncomment these two. These are adding different colors in to just make it more colorful pretty much. So if I restart, you can see that if you start again, you have this new prompt message that has a line in between. And if you like say do a random command like ls, this is really helpful to like separate all the separate commands you've done. And then when I did that, you can see the new colors that were added. So every single directory is blue instead, and all the files are white. And this can also really help for like distinguishing between the two. Okay, the last thing I want to do, we spent all this time on bash. I should probably give more justice to the other shells. So let's look at zesh or z shell and what you can do on that. So I'm going to go ahead and change shells, which is using this command, change shell -s /bin/zsh. And if I restart my terminal, I am now in the Z shell. And you can see it's a little bit different with what it shows you. And one thing that you can do with Z shell is you can add this this framework called zesh, and it allows you to download a lot of different plugins and different themes for you to customize your shell. Let me just give you an example. If I ls here, you can see the colors are also here. But also, if let's say if I cd and I press tab here, not only will it show me like the different, it'll show me the different directories that you can complete this with, but also if I press tab again, I'll be able to cycle through these different directories with the enter key. So that really helps if you like really can't remember what something is. And like I said, you can add a lot of different plugins. And ones that I've had right here, I've added here are syntax highlighting and auto suggestions. So when I press CD and like you can see it in green, that isn't already built in. That's something I added. And it really helps for when you're typing really fast and you need to see if your command's valid or not. So let's say if I wanted to touch like a file, but I accidentally went too fast, so I spelled touch wrong, like this, I could instantly see that I typed it wrong because it's highlighted in red. So that's really helpful for the workflow. And you could also see when I did something like this, like let's just say echo something, you can see that a long time ago, I already did this for a previous thing where I echoed something. Oh, sorry, echo is kind of a spoiler for the next section, but it basically prints something out. What I can do with auto suggestions is if I press the right arrow key, that automatically completes that for me. And it's using the command history as well. Great. That's all I had for my part. Thank you guys for listening. And let's take a quick break.
We'll come back in, let's do 5 minutes. And then it'll be my part, which will talk more about shell scripting. If you have any questions in the meantime, you can feel free to ask in the chat. Oh, and just for the recording, I think we missed a question beforehand about, so I'm just going to read it out. Does using zesh have any negatives instead of using bash, since the default in Catalina is zesh? And the answer from Tim is, in general, Zeesh and Bash provide a similar interface, so for general use, many commands should work on both. I don't think there should be any noticeable drawbacks unless you get into the weeds. And it's important to note that there are some scripting differences. So this is not a negative, but there are some differences in syntax. But even if Zeesh is your default terminal, you can still run programs in Bash if you have Bash installed. Oh yeah, another difference is, like, this messed me up for a long time, so I just want to mention it. But if you are using Z shell, you will not be using bash profile for your as the file that runs right when you open your terminal. It's zshrc, zshrc. All right, let's get started again. Oops. So so far, we've been talking about Bash in the context of writing like single commands in the terminal. But Bash is more than that. Bash is also a full programming language that you can write longer scripts with. And shell scripts are often used for configuration, routine backups, anything that you might want to automate on your computer. It's a pretty bare bones language with minimal data structure, so you You would usually use shell scripts to write something short and quick, but it's still very powerful. So shell scripting is mostly just like mixing up all the commands that we learned. You can use pipes, you can use like other programming language constructs like if statements, and after that you get a script. So how do you do that? Let's write our first shell script. So where is the, okay, anyway. So I've already opened up a new file in my VS Code. I'm not cool enough to use Vim. And typed in a shell script in a file called hello.sh. So this is something you can just run in your terminal as well. So I also have a terminal here in VS Code. And oops. Oh, maybe it thinks my quotes are weird. Well, I can't figure this one out yet. That's okay. Anyway, what this does is it just, let's just echo hello. Okay, for some reason it's unhappy about this. I'm not totally sure why, but again, echo just prints this out. We're just gonna echo hello world. Another thing to note about this file is that okay, so the exclamation point has to be escaped, but it works with single quotes. Okay, we'll get into that more later. Yeah, okay, anyway. And then this first line says run it in bash. Oh, it might be because I'm writing this in Z shell, and then this is how, this is saying run it in bash. So to run it, okay, to run it, it would be like this, but I get a permission denied error. And if you just create a file by default, you'll see that there's no X permission here. Oh, also, I should note that for this demo, it's not expected that you're going to follow along, especially if you're not on macOS like I am, and don't have the exact same setup. Probably different things will happen. And it'll be difficult to follow along. But yeah, when you create a new file, this is the default permissions. What the permissions mean is that, so the first dash actually means if it's a directory or not. So if I go up a directory, I see I have my shell scripting folder. And then if I use ls-l, you'll see this D, which means directory. So that's what the first dash means. Oh yeah, I don't know if this was mentioned, but if you do cd dash, you get to the most recent directory you're in. And then the next three dashes represent the read, write, and execute permissions for the user, which is yourself. And then the next ones will be the permissions for a group. So I'm in like a staff group, but it's just my personal computer. Let's say you're in like some organization, and maybe your group is your team or something like that. And then the last one is for others, so everyone else. And then in order to give everyone execute permission, I'm going to use a command called chmod. So actually, I'm going to clear this. And then I just give it the name of the file that I want to give execute permissions for. And then if I ls-l now, I'll see that my hello.sh file, sh for shell script, has these X's, which means that now we have execute permission. Cool, so now let's run hello.sh. And yeah, so yeah, that's actually a cool mistake that we made earlier. So notice that this one has, it doesn't give me that like end quote like weirdness, because in bash, it doesn't think the exclamation point is anything special. So notice, even though I have Z shell in my terminal right now, this like hash bang first line says run this file using bash. And since in bash, the exclamation point doesn't do anything, this is how it prints out. All right, neat. So the next important thing, if we want to write our own command line program, is it needs to be able to take parameters. So for example, if I want it to print, instead of hello world, it prints out a name that I give it. So let's say hello grids. I want it to say hello grids instead of hello world. So the way to access parameters in shell scripting is $, and then the number of the parameter. So in this case, this is the first parameter, so I'm going to use a 1. And then if I run this, again, if I press up, that's the shortcut to redo your last program or your last command. And then you'll see, yes, hello grids. And then if you wanted to do, if you want the second command line argument too, you can just say 2. So let's say hello ice bear. So the space means there's 2 arguments. So ice is 1 argument and bear is the second argument. And then we'll print those 2 as well. Another kind of special thing about bash is that there's a difference between double quotes and single quotes. So if I run this right now, it does not print out hello ice bear. It prints out literally $1 and $2. And so the difference is that the single quotes mean to take whatever is inside literally, but if you have the double quotes, it'll interpret the insides as like whatever special thing that it may be. So in this case, $1 is a special thing that means first command line parameter. All right, another important thing when writing programs is having a variable. So let's create a variable named name and save the first, whatever the first command line argument is. And notice that there is no spaces next to the equals sign that assigns the first command line argument to the variable named name. Like I really wanted to do this when I like learned shell scripting, but if you do that, you'll get an error. Like if I run this right now, it'll be unhappy. It'll think that name is a command, but it's not a command. It's the name of the variable that I want to use. So to access the variable, again, we use this $, and then the name of the variable. Hello ice, which is my first argument. If you have extra arguments, nothing happens. And similarly, if let's say we just say $3 here, I don't have a third argument, but nothing happens. It's just empty. Cool. Okay, so with those very basics, we can get started with a mini project. So this is a project that I made when I was taking 35L pretty much, which is where you learn shell scripting in 1 week at UCLA. But now you get another week because you have this workshop. So what this program does is the purpose of it is like, let's say you're taking math and you have like your textbook open and you have Paul's online math notes open and like lots of tabs open because all of them are useful. And this is also essential for math, watching We Bare Bears at the same time. And like hack stuff, like all this for your math class. And then, but you have too much open and you want to switch to physics, but yeah. So you just want to close all of them, but be able to open them again at a different time. So you have a program, we can mark this under a bookmark name. I'm going to call it math. And then let's say I just close everything and close preview. And then I do whatever I want, like say physics, don't study, I don't know. And then later on, I want to reopen my math bookmark. So I have another shell script where if I run it, hopefully it works. we get our textbook open, woot, and we have all our tabs that we wanted to save open. Yay. So for the next part of explaining shell scripting, we're going to make a subset of this bookmarking application. And yeah, just some context about it. It's just like something fun that I decided to do after learning shell scripting. So maybe it's not like the most efficient way or something like that, but you should be able to make it with Google and after this workshop. So the way it works is that it stores everything in a file called bookmark.log. And here it just saves like the name of the bookmark with the link. So all the ones that I just saved are under math. And I had some earlier ones that I'm naming the hack bookmark and the ACM bookmark. And then it opens these like particular links. Another thing about this application is that it only works for Mac because it relies on open. But there's an equivalent on Linux that's, I believe is XDG open. And then for Windows, like I'm sure there's something. All right, so in my setup already, I have my bookmark.log with my hack bookmark and my ACM bookmark. And now I want to write something that if I run bookmark.sh hack, it will open all of these links. All right. So there's like many ways that I can like filter this file down so that is only this link, but I'm going to be using two commands, grep and cut. So just to review grep, you take in a string that you want to match, let's say hack, and then a file, and then it'll look inside that file and then see all the things that it matches. Or see all the lines that it matches, which is perfect. So now we are able to find the hack bookmark. But notice that it also matches the middle of lines. And maybe that's not good because maybe in a different link, it also has hack, but we don't want that. So grep allows regular expressions. So a regular expression is a string that has some special characters in it that allow it to match more strings. So that's a little confusing, and we'll have a future workshop about this as well. But one simple example is if I put this little caret thing at the start of hack, it means only match hack if it's at the start of a line. And then I can also put a space after. So this will make sure I only match this hack and not hack in the middle of any other line. So if you see running this version, I only match the first hack. All right. Okay, and a note from Timar. You can use !number, which is a number to reference Oh, it's past commands. So let's say exclamation 2. That's like, I think that's what I did 2 commands ago. So that's neat. All right, so the next thing, after I have this output, I will also want to filter it down so it's only this link. I don't want the first part. So yeah, so doing this earlier, like when Tim's mentioned, hey, you can use cut. It's pretty easy to use, but I don't know how to use cut. So I check the man pages whenever you don't know how to do something. And like, honestly, it was a little confusing for me to read, but after some experimentation and like finding out that the -F option means which field you want to cut out. Let's say you want to cut out the second field. And then the -D option says how you want to separate the fields. So for example, like if I want to separate by spaces, the second field here is bear. The first field is ice. The third field is grizz, and 4 and so on. So if I run this command, I should get bear because it is the second field. If I don't put the -D, oh, I should have saved this or something. Then it doesn't know to separate them based on tabs. And if I read the man pages, it would say that the default is tabs. Or I think I said, yeah. So if I put -D, it knows to separate them by spaces, but by default it is tabs. All right. Oh, and the other important thing that I read from the man pages is that if you don't pass in a file, then it will read from standard in, which is important because this will allow us to take our grep command, oops, and pipe it to cut. So before I needed the second field because that is where the links are. So if I have this command, I'm able to get just the links. Neat. All right, lastly, I want to use open to open each one of these links. So the way to run open again is open and then the link. But if I have this whole command, I'm gonna put this command into my file. So now we're done testing things and it all works. So let's put it in the file because I want to be able to run my program. If I just try to pipe it into open, it's not going to work. So let's run bookmark. I also didn't give it any arguments. Or well, right now hack is okay. But it gives me this weird thing because open doesn't take the arguments, or it doesn't take things from standard in. You have to pass it as an argument. The other thing I want to change is change this to be the first parameter. Cool. Okay, so the way that I can use open is with something called command substitution. So if I wrap this command in backticks, that means replace whatever is in here with its result. So if I run this now, and pass in the argument hack, which is right here, then it will open those 2 links, the Facebook link and our beautiful website. All right. The other syntax for command substitution, which is what this is called, is with $, and then parentheses. So this is equivalent to the backticks. All right, and another way we can use command substitution is if we want to save the result of something to a variable. So let's say I want to count how many instances of the hack bookmark there are. I'm going to create a bookmark count variable and then use the grep command with -c, which means count, and then count the number of times we have our bookmark. Cool. Okay, lastly, if I type in a command that doesn't exist, I get this very unfriendly error, which is what happens when you don't pass something into open. So the last thing we're going to do is add a conditional, an if statement, to show, to count, or to make sure that the bookmark exists. So I'm going to use the bookmark count variable. So notice the $, which when I did this earlier, I forgot. This is what it looks like. So an if statement is surrounded by square brackets, and the square brackets have to have spaces around them. It's just another one of the things in Bash that you got to keep in mind. That's a little bit different. It has a then. And then else looks, and then otherwise I want to just say that the bookmark is not found. The other thing is that the if statement must be closed by a fee. So I'm not exactly sure why. I think it's because it's the reverse of if. All right. And if I don't have this $, and I run this, then it gives me this weird error, integer expression expected. Yeah, so that's all you need. Oh, the $. The other kind of weird thing is that you don't use the brackets for greater than and less than. When comparing numbers, you use -gt for greater than, -lt for less than, and -eq for equals. And there's a few other ones like less than equals. I think it's LE. Yeah, but there's definitely documentation. You can check it. So yeah, so what this says is that we count how many bookmarks for the one that was passed in. If it's more than 0, then we can open them. Otherwise, we will just have this friendly error, bookmark not found. So for example, now it says bookmark not found, but if I type my ACM bookmark, so the 2 bookmarks that are available are hack and ACM, then it will open our portal, membership portal website. And then this is our YouTube channel where you can check out recordings of hack events and cyber events and anything else. Woo. All right, so that is it for this part of the demo. If you're interested in the rest of the project, feel free to ask me. Otherwise, we will be going through some other cool things you can do with shell scripts. So at the end of the README, I put some links. This is the code for the bookmark application. This is something that's kind of cool. It's also made with shell scripting, and it gets the synonyms for words. So, and also in different languages. So if you want the synonyms for happy, the French synonyms for happy. And then the other link is this very long list of different command line applications that you can use that vary from development to file managers to GIF creators. Not all of these are shell scripts, but it'd be kind of a fun exercise to try making them using shell scripts. A lot of them are like in JavaScript or Python. And yeah, there's Vim and Emacs. No preference for me. I don't know how to use either. There's some fun ones like this one that magically corrects your previous console command. Oh, there's TLDR. And you can even have a fireplace. I thought this one is quite fun. You can just run it and it turns into a fireplace. Yeah, and that's it for our workshop. Feel free to ask any questions, and thank you all for attending, and also thank you for asking questions in the chat. It really helps like keep the interaction and like makes it a lot more informative. Thanks.
All right. Good job, Christine, Eugene. I was clapping my little reactions thing because that is all I can do. For coming, just as Christy said. The next topic is going to be LaTeX. So, like as in next week. So if you're interested in writing very like good-looking academic papers and or like even just like making your homework, I think I cut out. Well, that or making your homework like look very spiffy and good. That is a workshop to come to. So. Did I cut out? Or...
No, you're good.
Oh, good.
Well,
Okay, almost. All right, Eugene, you should probably stop the recording though.